welcome to this session. I'm Harry Forbes from ERC Advisory Group. I apologize profusely for the delay in starting this session. It's entirely my fault. There was something, I think a loss of metadata or something caused us to lose one of the two presentations, which is now being retrieved by SneakerNet. So I will begin in this topic. This session is IoT Network Edge, Infrastructure, and Devices. So the format for this session is I actually have a little bit to talk about and present for this, so I will present first. The following my presentation, Simone Schiaffetti from Fincantieri North America is going to present an application, and then we'll have a panel discussion with three other panelists and Simone to discuss edge technologies. So if you have questions, feel free to jot them down, and we'll have plenty of time with only two presentations to have some discussion. I don't know if you were in the open process automation session that was just earlier, but if you were, you can certainly see there's an awful lot of overlap in ideas between edge computing and open process automation. And truly, edge is one of those buzzwords that people get sick of. And one of the reasons that people get tired of it, if you will, is because it's difficult to get a standardized definition. Where the edge is kind of depends on where you are working, what kind of things you're working with. If you live in the middle of the country, then you think the East Coast and the West Coast are the edges, and you don't necessarily like them. And you have a different perspective if you're with a telecommunications carrier, if you do enterprise IT, or if you do automation. But everybody is talking about the edge, and even in applications like smart grid, there's a lot of discussion about the edge. So it's a term that's kind of useful, but not very precise. So what I would like to talk about is to put in a little bit of an automation context for what we see at the edge, and then go over some of the products that we have seen at ARC in the last year or two that are, I would say, indicators of what's coming at the edge. And then we'll have Simone's presentation, and then we'll see, how that stands up, whether there's much agreement or not. Typically, let's see if we can get the old clicker to work. Folks, is this working? Do I have to aim it a certain way?
Point to the PC here. The PC over there.
There? Sorry? I think this session should be called Murphy's Law. There we go. Okay, thank you for now. So, point it this way? Yeah. Okay, thank you so much. This is in an automation context, and this is something I wanted to talk about earlier in the session, but because of time did not in the session earlier today. This will have relevance in the automation space. I don't know that it will have so much relevance in other spaces, especially IoT. But in the automation space, you heard, if you were in that session, talking about three aspects, or a couple aspects of application portability. This figure, if you will, is drawn from, of course, the laser doesn't work either, does it? Yeah, it kind of works, but I don't see it. This is drawn from IEC 61499. It's enhanced a little bit. But IEC 61499 talks about three aspects: configurability, interoperability, and portability. And Obviously, in the industrial automation space, we have a lot of technologies for interoperability at the edge or at the device level. Things like even HART, going back to the 80s, DeviceNet, Profibus, and on and on and on. A lot of different technologies that are standardized and available for managing the interoperability of automation systems. In the automation space, the definition of configurability is one that's a little bit, I think, too traditional and kind of weak in today's worldview. Configurability we think of, at least in our traditional sense, of going to an engineering system, reaching down into a device, manipulating the parameters of the configuration of that device, whether it's an I/O module or whether it's a PLC or whether it's a DCS controller. We manipulate the parameters in that device, in the target device, and then leave. So it's reaching down across a network into a device, adjusting its parameters or configuration, and then leaving. And portability really refers to being able to move the source code, if you will, some representation of a configuration and application in some form of language expression from one tool to another. Now, in cloud jargon, I think these words are expressed differently in what they mean. The cloud jargon is, we'll talk about things like deployment and orchestration. And what they mean by deployment is they mean building your application and moving your application to the place where you want it to run, starting it up, and orchestration refers to monitoring the state of that application and managing the scale at which it's deployed and keeping track of the health of the application. So we have kind of different terminologies in the automation space and the IT space for these technologies, but I think the important one is to think of more of deployment and orchestration, because I think the kind of model of moving into a device and manipulating the device itself over time is going to go away, as I'll point out later. This is a detailed model of forecasts for the software development world over the next 5 years. Traditionally, we've had a number of different software technologies that have development technologies now that have been, to some degree, distinct. And most especially the embedded software technologies have been distinct from the edge, the enterprise, and the cloud. But if software is eating the world, in my opinion, it's likely that the software development for the cloud will eat the world and begin and finally finish with the embedded systems. And there are aspects of embedded systems that are really not well suited to the cloud, especially making that very small footprint, removing all kinds of dependencies and extra code that represents a resource consumption that's not necessary and also represents an attack surface. So embedded systems have worked that way mainly because of resource constraints for many, many years. But in my opinion, the models that are going for future development on the cloud are going to take and do some of the very same things that embedded system developers have done for a while. So while we've had those three different classes of development, really the first phase of development tool convergence that we're seeing now is what's called the buzzword of cloud native computing, which means developing enterprise applications that are native to the cloud. You're not moving an application to a cloud infrastructure. You're developing an application to run native on the cloud. there's a great deal of standardization work going on here, and a lot of the standardization has to do with standardizing the runtime environments that are found in the cloud platforms. And this is analogous to a need in the automation space and in the IoT space to standardize the runtimes that are available. The second phase of that convergence, and again, this is all wing and a prayer opinion, so if anybody disagrees, you're welcome to. The second phase of that, and the reason it has impact for automation and for IoT, is because these technologies are not limited to the cloud in terms of software development technologies. The kind of technologies that people are using in cloud computing have already been shown to scale down to very small footprint systems. So we see this now in the edge products that I'll show in a couple slides, but the limit has not anywhere near been reached now. So I think we'll see these kind of cloud tools scale down as right now we see, for instance, a lot of the edge computing products in the last 2 or 3 years include the ability to run Linux containers and use the Docker tool for deploying and managing Linux containers. We've got a half a dozen products or more on the market that do that. But soon, I think we'll have what are called Eunuch kernels, which are basically an embedded system image that moves into and runs directly on a hypervisor so we'll have kind of cloud-like runtimes in embedded systems. Oh, one other point about that is that these kind of technologies move forward with open source speed. We're used to thinking, oh, we have a 5 or a 10-year deployment horizon in the industrial automation space before something gets into the mainstream. But the tools that are open sourced, they were in development for years before that, but tools like Docker, Kubernetes, OpenStack, Cloud Foundry, those are really relatively new by our industrial standards. And they are very much in ferment. In other words, the existing cloud stack, if you will, has a lot of redundancy and a lot of waste. And cloud people realize that, and they're actively working to reduce that waste and improve both the performance and the cost of the services that they offer. So in terms of this Docker, what is it and what is a container and why does anybody care? The reason that, and the container is a crazy thing, it isn't really a Linux thing you can put your hand on and say there's a container, it's a collection of stuff. But what really made it take off was a tool called Docker, which is an application delivery technology. So it's a way, this is a great quote, I think, it's an application-specific way to deliver scalable applications on the infrastructure of your choosing. So what it lets you do is it lets you package an application with its dependencies, and you can manage that as a class. So if you have it on a different platform, it can have different dependencies, and you can push it out to any number of target systems to run. So it's a deployment technology, and this is being standardized now. This kind of container technology is being standardized in the IT space under the Linux Foundation by a thing called the Open Container Initiative. And I just circled a few of the companies here that are involved in the Open Container Initiative. Actually, I didn't circle Alibaba because I don't read, but Amazon, Facebook, Google, IBM, Microsoft, Oracle, and Alibaba. If you add up the market capitalization of all those companies, you're probably into trillions of dollars. So these are major software companies that are working to standardize and improve this kind of runtime environment for the cloud. If that shrinks down to the ability to run in edge systems, which I think it will, or variants of it shrink down to that level, we better be ready. the next step, if you will, for a cloud stack is something called a Eunuch kernel, which is quite controversial, and it's really a research topic at this point in time with some very knowledgeable people pursuing it. Their thinking in part stems from looking at the existing cloud stack. If you think of the way applications are deployed, you have a host operating system, you have a hypervisor, then you have a guest operating system, then you have an application. And maybe you have containers on top of that application. Not very efficient. In other words, you have a couple of operating systems in the stack. There's a big attack surface. It's obviously not optimized from a footprint or attack surface or a performance standpoint. But we throw enough resources at it, which the cloud has plenty of, and we can make it work. The idea of the Eunuch kernel is to apply basically the same technique as a container to an entire operating system. So I basically do what an embedded system developer does. I pull out the dependencies that I need, build those into my executable, and create an executable that will run on that runtime environment, which is also standardized by the same, there's not one runtime environment, but either a hypervisor or a standardized container-based runtime environment. There are 6 or 7 tools on the market for this kind of technology. Their implementations are kind of different classes of them. The characteristics that are attractive for people in the IT space for this are the same ones that I think we'll find interesting in the edge. They're a very small footprint, much higher performance, and a low, very small attack surface. Because if you build, in a sense, a customized application plus operating system, it's not really like you have an operating system, it's like you have an application. Even if an attacker gets access to an application, it doesn't do that much good because all the applications are different, so you can't really attack. You don't have a common attack surface that is shared across many, many different applications. It's much, much harder to attack. And there is another funny quote about this. This gets to be a religious argument among the IT people, whether this is a good idea or not, and the cloud people. And one of the funniest quotes I heard was somebody say, well, anybody who advocates Eunuch kernels should be forced to smoke the whole pack, meaning, you shouldn't toy around with this stuff. It's not a good idea. So it is very much in the realm of religious debates and R&D now, but with the amount of investment in venture and capital coming into the market, believe me, it's getting a lot of attention. So now let's turn to kind of what the generic benefits of edge computing are. Why do we have edge computing? What are its advantages? And why do we want to put automation on the edge, as we are seeing in a number of products? Well, first of all, we can take advantage of new technologies. And these are the kind of hardware and software technologies that I've been talking about, or software technologies especially, in terms of open source software, package management, application management with containers and so on. And this is really a supplement to the existing cloud computing model. If you look at the so-called fog computing model, this was developed when people realized that it was relatively easy to put a fair amount of storage and compute resources at a location and do significant amounts of work there rather than just move data back into a cloud. And especially for some applications, that was not practical. So that was kind of the genesis of edge computing. And again, a problem with the buzzword is that both edge and fog kind of mean the same thing, although there is a reference architecture for fog computing. But why do you want to have edge automation? Well, it's able to leverage basically the same kind of tools. So you can take and host in an edge device automation functions, IoT capabilities and IoT applications, and other applications as well. So it's kind of like a little bit of a general purpose, and some of the examples will point this out. And you have, in many cases, better development tools or superior development tools, meaning that they're not, I'd say this charitably, they're not legacy tools for the automation space that come from the 1990s or the 1980s even. And you have superior deployment and management capabilities with the same kind of open source technologies for Docker containers or management. So why will it be important for automation? I think a container engine may become a common embedded runtime environment. We're already seeing some of that. And in the open process automation space, a lot of what they are trying to do is standardize on the Purdue model level, layer 1 and layer 2 automation applications. And it's very possible now to deploy these in certain applications, just like we deploy software in the cloud, but pushing it out to the edge. So what that means is that the development workflows will be different. They'll be much more like IT. And the industrial automation embedded system technology will start to follow the cloud development path. And like those fish eating each other, eventually what's today an embedded controller will eventually become an application that gets pushed out to a device on the edge of either IoT network or an automation network. So the implications for this, for automation, are pretty profound in that it enables end users to deploy multiple automation development tools. If you want to write your application in C++, if you want to write your application in Java, if you want to write your application with an IEC 61499 tool, nobody cares. It's like the cloud in that nobody too much cares what you develop your application in, as long as you can integrate it with the platform. You're language independent. So, and the other thing that I think will be important as end users catch on to this, and I think they will because of the products, as they catch on to this, their expectation is going to raise. Now we know already, and we hear it all the time in ARC from end users, that it's unattractive for people to keep working on old software tools. But this will make it even less attractive as this technology becomes more popular and more widely known. Finally, it offers, in some cases, I won't say in all cases, but in some cases it kind of can break up or converge the dichotomy that we have in the industrial automation space between PLCs and DCSs. If you think about it, there's a wide variety of applications where the distinction really doesn't carry much weight anymore in terms of what's going on or how it could be addressed. And it's really not my space to comment on the rise of things like IPCs. I'm no expert there. But for a lot of applications, for a lot of DCS applications or PLC applications or applications that use both, the distinction really doesn't make a lot of sense. And finally, management at scale is a common theme in both IoT and automation. So in industrial IoT applications, we look and say, if I don't decrease the cost as I roll out 10 or 100 or 1,000 nodes in an IoT application, it doesn't work. You really have to scale down the costs, and you have to manage economically at scale. That's also common to automation, because as automation people try to shrink the size of the modules that they're working with or the applications that they're working with or distribute them much more widely, they're going to be stuck needing that same kind of management at scale. So let's look at a few examples. I'll close by looking at, I think, roughly a half a dozen examples of this kind of vision. Some of these are real products right now, and some of them are just plain visions. One of the first ones was what's called Cisco IOS, which started out being, excuse me for paraphrasing what Cisco does, but we'll put a Linux box into our switching infrastructure, and we'll let people run applications in it. This became, in 2014, we'll put Docker containers in our Linux box, and you can push applications out using Docker into our infrastructure. So this was envisioned for a number of smart grid, smart city kind of applications. And really it was the addition of the Docker capability that helped it to become much more practical from a customer standpoint. But that was one of the first of these kind of activities that I saw. Another one that just came out is kind of close. It's not exactly the same. It's called PLC Next, and it's a new product that Phoenix Contact introduced at the SPS show last November, but they had had it in the works for at least a couple years before then. And their idea is a little bit different in that what they want to do is they want to free application developers from particular tools. So they create, if you will, a kind of sandbox, and my laser doesn't work, but on the right you can think of that as an application sandbox where the middleware function performs a global data synchronization function, so that you can have a set of applications that you developed with any number of tools, and they can synchronize their data internally using that middleware without knowing it, if you will. The host API provides that capability. So this enables people to work and develop applications, and their thinking was, well, we have people that want to build stuff in MATLAB, or they have stuff in MATLAB they want to put into this box, or they have something in, 1131 tool that they want to put into this box. So the idea is to make it easy for them to use any number of tools. Again, it kind of fits the company business model that they have. This is one that came out in 2017. I'm not sure I have the branding all right, so I apologize if I don't. But it's called NetIOT. And this is a edge software platform that was introduced hardware and software platform that was introduced in 2017 by Hilscher, kind of combining their expertise in industrial automation and industrial Ethernet protocol stacks with the ability to add software packages from third parties, and they ported the Docker application into it. So it's a quite capable edge piece where you kind of see it has support for a lot of industrial automation infrastructure, network infrastructure and protocols, as well as different application tools, and just an operating system platform on which people can run applications. This is another 2017 one. It is commercial, I think. This was done in a collaboration between TT Tech, I think that's the right way to pronounce that company. It's an Austrian company that's been on the forefront of time-sensitive networking for Ethernet, and a venture firm out in California called Nebbiolo, which is, I think, a kind of Italian wine. I'm not an expert on Italian wines, but they work together to create a combination infrastructure and edge platform. So what they put into it, the Nebbiolo folks were experts and kind of were Cisco spin-offs, so they were developing the fog computing reference architecture within Cisco and started their own venture. TT Tech was much more familiar with the automation space, so they have they have ported the Codesys development environment and Codesys runtime. They have Docker, and they have a VM that they can let people play with or run their own application on, all in this infrastructure with a number of interfaces. We were hoping to have a presentation on this in an application at this event, but it was not ready for prime time. This is one of the kind of cool ones, in my opinion. This is a venture, kind of an international venture, and it's not really sure where. I guess their headquarters technically is in Seattle, but they're a highly international little venture called Resin IO. And what they have done is basically port the Docker container engine down onto single board, small footprint computers like Raspberry Pis and BeagleBones and other things that get embedded in IoT applications. So they came at this world from the IoT angle. They did some IoT work and found they had cost problems scaling. So what they did was they developed a Linux build and they ported the Docker container engine into an ARM platform, and they offer that, and they support a number of different, $20, $30, $40 single board computers on which you can run this and push your applications out regardless of where they are. Now here's another more commercial example on a different scale, and that is General Electric's so-called Industrial Internet Control System. I think that's the brand, IICS they call it. And what they have done is take an existing set of functionality that they had embedded already in proprietary equipment in earlier generations and moved it out into a virtual environment similar to what you can find out on the floor here. So they have an on-premise cloud that is running virtualized the old applications that they had for automation and management of some rotating equipment, including gas and steam turbines. The interesting part about it is they left the safety pieces. There's obviously safety and machine protection pieces in the existing platform, but the proprietary hardware is now only running the machine protection safety functions. The automation functions are all running in the virtualized platform. And I don't know what else they're running, but this is kind of something that we expect they will be developing going forward. And then if you were here, this was introduced on Monday at the ERC Forum from one of our sponsors. This is called Groove Epic. It kind of combines PLC and HMI functionality. What I think is noteworthy about this, it doesn't have, it didn't embed Docker, but what they did do was they have a combination of third-party software, being Ignition from Inductive Automation and Codesys, along with standard, along with open source. The Node-RED application is an open source application, and their own application, and along with OPC and MQTT. So they're kind of making a useful base level platform for their channel, and the way their business works is they move everything out through channel partners. So this gives their partners a leg up in terms of working on an application or extending it to a particular customer. So you can see there's a number of these kind of products. All of them have come out in the last 2 or 3 years. And the development of the container technology is accelerating this, I think. And of course, if you go to the IT world, the containers are I can't think of a family-friendly way to say it, but they're the hottest thing on the block now. Another example, which was in the session earlier, is this Open Process Automation Forum reference architecture, which they did talk about a prototype or proof of concept implementation today. So this is a very well-known diagram if you've been to the ERC forum, but this is a vision for future process automation architecture, which incorporates legacy and includes much more easily replaced technology and replaceable technology. And this has been demonstrated now, and they just reported on their first demonstration or first proof of concept system. And finally, so what I would say, that they have a vision, and my laser's not working, but it just doesn't work. The so-called, this little piece right here is called that's called a distributed control node. It's kind of either an I/O card or a I/O card plus single loop controller. So it has a little bit of compute, a little bit of storage, but there's potentially different ways to skin the cat there. But what they are seeing is, well, we want to be able to run applications in there. We don't want to just use I/O. That's their vision. And that DCN platform has a lot more compute storage capability than the little Raspberry Pi boards that I was showing a few slides ago in the Resin IO. So it really is the kind of platform, or easily could be, even at competitive price points, that would be able to run some form of container runtime along with various field bus interface applications and process control applications. And potentially now it's a sophisticated trick in the DCS world, or it was in the 90s, to do an A/B switch where you'd have an application running and you have another application. You'd switch over to the revised application. If you didn't like it, you could switch back. That requires some resources, but that's kind of standard protocol in the cloud world. And AWS and other cloud infrastructure providers have that as a kind of a parlor trick that they have to support. So you could even get this down at an application level into these kind of edge platforms in the distributed control node, I think at a reasonable kind of price point. So what does this mean for automation? My projection is that these kind of cloud and technologies are going to extend to the edge in terms of the development and deployment of software. So we will see not 1 or 20, but 1,000 or 10,000 network devices with automation pieces or IoT pieces that will be much simpler and less critical. But since there's so many of them, you have to make the management and deployment work 100 or 1,000 times easier than it is in a proprietary system. So we're seeing a much greater level of hardware independence because the cloud software tools let you manage those dependencies at a cloud level and then push the resulting builds out to the automation or target systems. Because of open source and because of the applications in those products, if you look at the products, you see a big preference for Linux over RTOSes. The reason for that is, well, basically you have a lot of control, you have a lot of compute capability at a very low level compared to legacy systems or historical systems, but also it just moves fast. And there's a lot of development going on in that space. So this will certainly have a lot of if this comes to pass, there'll certainly be a lot of business level changes in the automation space, which I can, would be a good topic for discussion. I don't want to pontificate on what they might be, but obviously it represents a big change in the structure of the industry, and I think it brings much more importance to the roles of system integrators, which is not to say that existing suppliers can't take on that role, but I think the system integrator role is going to become much more important. So with that, thank you very much for putting up with my pontification.